I guess we are ready to start. Hi, everybody. Welcome to the last day and last panel of the Smart 2021 conference. By no means, although it's the last panel, by all means, I believe, in my personal opinion, is one of the most exciting panel we gonna have in this conference. The title of the panel, as you have seen, the program is about the 6G testbed, or what are testbed requirements for 6G, from reality emulation to complete disaggregation of the networks. My name is Reza Nejabati. I'm a professor in a Smart Internet Lab, and I will be hosting this panel and chair and moderate the discussion. We have a fantastic set of speakers. First of all, they will put their view very briefly about the topic, and then they are basically available at the panel to answer the question and open the debates. I give a very quick introduction before we go ask the panelists to present their view. We have Ben Allen, the Director of System Modeling from OneWeb. We have Maria Cuevas, Project Manager of the Mobile and 5G Research Team at BT Lab. And we have Paul Harris, Senior Standard Strategist at Vodafone. We have Dritan Kaleshi, which is Director of Technology at 5G Digital Catapult. And we have Manimohan, Head of Digital Infrastructure and Policy Regulation at GSMA. And we have Robert Piechocki, which is a professor at University of Bristol. So as you can see, we have a very distinguished panelist. So without any further ado, I asked them to basically go ahead and present their view about the topics. We start from Ben. Ben, please go ahead.
Yes, good morning, good afternoon, everybody.
I am sorry, Ben. Apparently, we have Maria's first. I don't know.
That's
sorry,
fine.
This is a logistical issue. Maria, go ahead.
Thank you. Thank you, Reza. So good afternoon, everybody. As Reza said, Maria Cuevas, thank you for having me here. If you'd like to move on to the next slide, please. I would like to share some of our views on the topic. So we know that there is an awful lot of discussion as we speak on what 6G should be all about. We have views about it, and we have been sharing them across many different conferences. And we think in order to address this particular question, we do need to provide a little bit of our view on 6G, not expanding on it too much. But we're very keen that we're looking at solving real world problems. And we're very keen that we're not just setting ourselves a 10 times better than 5G sort of target. And we step back and think about what other issues 6G needs to be resolving. Here are a few, not all of them, but we think coverage has to be absolutely key. It continues to be a problem to be able to deliver cost-effective coverage to all areas, and this includes both, obviously, rural coverage as well as indoor, has to be at the forefront of what we are exploring with 6G. We absolutely need to be looking at energy efficiency and ways of optimizing the way we run our networks. Increased security, which, as we know, has been significantly increased in 5G, but we do believe that there are obviously imminent threats or future threats coming our way where we do need to rethink the whole approach to security in mobile networks. And last but not least, the way we automate our networks, and that could be coupled actually with some of the energy efficiency comments. There's one I haven't mentioned here, but I would like to explicitly bring up, which is the improved reliability of our networks. And there is a school of thought that says, yes, we are making obviously 5G ultra reliable and all the rest of it. But then when it comes to delivering SLAs to our customers, we still struggle to set specific SLAs. And what's happening is, I suppose, application developers go around our networks and continue to go and develop their solutions to ride on top of any network whatsoever. So I think that reliability angle is often not completely ignored, but I suppose not given enough or sufficient importance. The main reason for saying all this is that, again, when we're setting our testbed requirements, we need to bear in mind what is it that we're trying to achieve and what is it that 6G should be trying to solve. So again, as I said, performance requirements need to be driven by real world use cases. And of course, the testbed requirements will have to be focused on what particular technology we're trying to develop or test. One thing I have skipped over in this slide is another key area that we're very keen that industry explores and really seriously considers at the outset of 6G development, which is how do we support 5G NR capable devices moving forward. We don't want a step change across our networks. We don't want another radio that is introduced that doesn't support previous devices. Whether it is by extending 5G NR into 6G, whether it's by coexistence of a new radio potentially with 5G NR in some form of dynamic spectrum sharing arrangement, that is all to be seen. But that is one clear message from us that we do need to consider, if you like, the upgrade path for an operator to be able to deploy these things. On to what we think the testbed requirements should be. There are probably three main points that I would like to highlight. First of all, is enabling us to test practical performance rather than theoretical performance. So what do we mean by that? I believe one of the presenters later on is actually going to be talking about hardware emulation. So I'll probably let them expand on that topic. But one of the things that we are very keen and we are already deploying in our test beds is more hardware emulation capabilities that take us beyond pure computer-based simulations, if you like. And one of the reasons why we need to do that is because we need to identify practical challenges early. And the main way to do that, or one way to do that, is obviously by emulating things in hardware. There is another aspect to testing practical performance, which is actually, so we all love an iconic chambers, and they give us a way of isolating problems and testing radio environments. And that obviously is always going to be one step along the research process, but clean radio environments, as we all know, are unrealistic, which is why, again, deploying what we call lab to live radio environments is going to be very important. We again try to deploy as much live radio as we can that we can actually use for our own testing. And actually that might be where interconnecting different labs with different live radio environments is going to be very helpful to get us all understand different environments and adapt the assumptions that we make on emulations and simulations and all the different processes that we run in our labs to adapt to real world conditions. And it's all back to that point I made earlier about making sure that we are addressing practical performance. In the interest of time, I'm not going to dwell on the next two, but I did want to highlight, obviously, one of the key titles of the session is highly distributed architectures. So we completely agree we need to evolve our, again, testbed capabilities to explore the issues that we need to overcome when we're in a highly distributed system. We need to emulate transport network capabilities. We need to be able to orchestrate across different domains in the architecture. And timing and sync capabilities are going to become increasingly important in order to do that. And finally, last but not least, AI, as we all know, is likely to be a very key element of 6G technology. So we believe we need new test methodologies. We need things like AI explainability to be entrenched in everything we do, even at a research level. And I see as well that Robert is going to be covering digital twins later on, which is a very important topic for us. And we do believe that, again, our test beds need to be equipped with the ability to almost develop digital twins as we develop the real technologies that we're going to be deploying in our networks. So that's me. Thank you very much.
Great. Thank you, Maria. That was a great view. And then our next panelist, Paul, please.
Thank you, Reza. Yeah, so I think probably that follows on quite nicely as expected. Maybe some of my views and Vodafone views are, are somewhat aligned with much of what Maria's just expressed for BT there. So I think I'll just give a bit of a general overview of the perspective and perhaps some of the more specific details we can cover a bit later with Q&A. But I think the main thing from an operator's point of view, from our point of view at Vodafone, is we of course also believe it's important that everything to do with 6G really has a strong focus from the ground up on applications and services that are directly driven by a clear industry need, and any 6G testbed should be developed with this in mind. So I think, again, as Maria said, stepping back and re-establishing this perspective is sort of key ahead of talking about any specific requirements for a testbed. So that's why I'd just like to go over this. I think, again, we wish to avoid entering too much of another hype cycle where we chase kind of 10 to 100x gains in speed and latency without perhaps some clear alignment with the use cases and applications that are driving those. It's of course always important that there is absolutely space for more blue sky exploration of certain things, but I think it's crucial that what we drive and market as important for 6G as a global communication standard should stem from that customer and industry demand. So our view also on the mobile technology point, so 5G NR, I mean, that in itself already has the theoretical capability to support multi-gigabits per second service, and therefore will deliver speeds expected for what we can see for the market for the foreseeable future. Exceeding that anyway is likely to be largely impractical in many cases with power consumption, spectrum requirements, site densification, etc. So in many ways, we kind of expect that in terms of the core radio technology, the current both 4G and 5G NR networks, either in spectrum sharing or as we move towards standalone NR, will kind of remain networks of choice to deliver many of what 6G capabilities may be. And I think that reflects a lot of the development over the last 30 years in mobile radio techniques that we've rapidly approached many of the theoretical limits with those. So I think key priorities for 6G therefore, and how we establish a testbed, would be to work on improving the simplicity and technology scalability and stability, encouraging with the distribution aspects the Open RAN supplier diversity, making sure that we factor that into any sort of testbed requirements by default, that disaggregation is at the core of what we're trying to do, and that we have that longevity and certainty with the type of technologies we're using. So I think we therefore need to just consider this in a little bit of a different way from past generations, not necessarily gutting all the radios again and deploying brand new radios, but rather than focusing maybe purely on data rates, that other aspects, optimizing power consumption, private networks, bespoke connectivity, and industrial users and new verticals are likely to be the more important factors. So yeah, that's me for now. Thank you.
Great. And after this comprehensive view from Vodafone, let's go to Dritan to see what is the view of Digital Catapult.
Good morning all. Thank you, Reza. Of course, really pleased to be back to Bristol, even virtually, and thanking the organizers for inviting. So the theme is about testbeds. And as a concept, testbeds often are generalized, misrepresented, as misunderstood when they are discussed at a conceptual level and away from what Maria quite rightly put, which is a specific purpose or objective. And that is primarily where I've tried to focus when I was thinking about this this topic. What is the purpose of a testbed as a generalized tool? There will be all sorts of testbeds, from something that will test radio air interfaces to something that will test what today we call fronthaul and backhaul interfaces, etc. But for me, there are kind of 4 key points to make around the difference that we will see in 6G as a direction of travel. First of all, it looks to me that we are moving relentlessly from talking about individually communication systems to talking about information exchange systems, i.e. this combination and convergence between compute and connectivity, which in fact will emerge by 2030, and it will serve the world that is very different from what we have today. The second point for me is that the pace of the technology development is accelerating, with more and more penetration of the software and software agile developing processes affecting everything. A third point is that it's very, very clear now, and it is very, very clear in 5G, and picking up exactly very nicely from what Paul said. And we haven't rehearsed this before, trust us, but we are looking at vertical industry support and enterprise, and that is still quite a big challenge. And part of that is the communication subsystems cannot be designed anymore in isolation from the rest of the information infrastructure, like considering the classes of applications like digital twin or metaverses that we'll need to talk. And to address these last 2 points, it is absolutely crucial to use end-to-end interdisciplinary testbeds that can effectively bring to the fore in a real-world environment the interplay between classes of application and the services that they require and the future networks that will enable these things. So what I've done in this diagram is that we take the usual layered view of what we call a digital infrastructure technology stack. Already we see an increased interaction between the different parts and layers of the system, flexibility in the service provisioning. Anita, if you can click next one or two times, please, which are making the connectivity and the compute services more visible and more flexible between one another. Anita, if we can click, yeah. So if you look at these 3 layers, and again, please, Anita, we see a shift of the interfaces between the different layers that is moving, like a water field model, upwards and upwards. And this kind of shift between and convergence between the connectivity and the compute, 5G has already started from internally with a service-based architecture to the reach out in mobile edge compute and network slice and orchestration, and trying to bring this together, but it is only a start. So if we look now, and Anita, if you can click a couple of times, please, as well. One more. If you look at the 6G, the way that 6G is described, one more. The way that 6G is described, it's all of these features, intelligent connected management and control functions and everything else below that. But the key thing for me that stands out is this aspiration, which we will see how much the next 10 years will deliver, which is supporting the easy integration of everything. And for me, that is a very, very distinct shift from what we have considered always in terms of coverage, capacity, data rates, speed, and latency, into something that effectively needs to be designed in a completely different way, because it is supporting easy integration of everything, requiring a better integration with the other layers. And in the same way as Paul said, often technology development is marketed as driven by killer applications, but in reality, in communication systems, the only application that has always been successful has been the information exchange in different forms, from clay tablets in exchanging something at the beginning to Instagram and TikTok that we have today. And if we look at this space for the future, that is where we need to effectively see what requirements and what set of tools the digital twins and metaverse, things that will start to emerge in 2030, which is the service era for 6G will bring. So the network system infrastructure is at the moment supporting integration of everything. What new tools do we need for that? And my argument is that apart from the fundamental and applied research to validate and take forward kind of the individual theoretical fundamental advances required in communication system subblocks, from semiconductors to network management, we also need to have these very, very large, stable, long-term, evolving interdisciplinary test beds that will allow early testing of the technology blocks, not only in terms of the performance, but more importantly, in terms of how they integrate with one another in order to provide a very, very flexible service infrastructure, digital infrastructure, that we will need to support the digital twins and the metaverses of the future. And as a last thought, it's quite interesting to look at the different definitions of a metaverse as a next stage of the digital twin. But the one that I particularly like is metaverse is defined as a future iteration of the internet, made up of persistent and shared 3D virtual spaces linked into a perceived virtual universe. But the connection there is that it is the future of the internet. And what we are discussing with 6G is how that future internet will be delivered. And the testbeds to be delivered for that should definitely be end-to-end interdisciplinary testbeds.
That's great. Thank you, Dritan. Very comprehensive view as well from Digital Catapult with a very much future-looking view. And the next presentation is from the GSMA. Mani is gonna tell us his view.
Thank you, Reza. Good afternoon, everyone. Thank you for inviting me to share my views. For those who don't know us, GSMA is a global mobile industry association bringing together and representing more than 750 mobile operators around the world and 400 other entities in the broader mobile industry. So the theme of this session kind of touches on 6G or beyond 5G networks, disaggregation and testing. It's a bit difficult to go last and talk about to add something to what already has been said. So I'll try my best. So we had a Future Networks research conference. So what I really wanted to say are some pieces which I think will be important in beyond 5G networks, and also some of the research questions that I believe need to be addressed. So mobile for me is a huge success story. There are more than 8 billion connections, including cellular IoT, that are connected to mobile today. It's fundamentally about connecting people, and I think over the decades, that the technical challenge of efficient transmission and error-free communication reception has been solved, and is increasingly that frontier has been pushed forward, either dealing with wider bandwidths or with high frequency spectrum. And with every generation, data used per user is increasing, download throughputs are increasing, and price per byte is decreasing. So that's what has led to this huge success. And I believe that this kind of trend would continue also beyond 5G requirements, but as Maria and Paul said, maybe they should be tempered by the real demands of the user population and applications. But there are also more than 3 billion people who are not connected to the internet today. So they live in areas where there is a mobile broadband signal, but they still don't access the internet. There are many theories around it, and really my kind of first research question around this that I pose as a challenge is we need to kind of dig deep and understand why these people are not connected to the internet or not willing to access the internet. And then there are many theories around affordability of devices, etc. And one hope is that maybe disaggregation, which are currently being tested, the testbed for open RANs are primarily in rural areas for different reasons. But maybe these trials will give us more insights as to why and how this particular challenge can be solved. The second aspect, of course, is very good, I think, to push forward the technology frontiers and have new technologies coming into market. But the commercialization of those technologies is also a challenge. The mobile industry is a $1 trillion industry globally, but all the forecasts around revenues are that it will remain flat over the next few years. So despite creating more and more technologies and more features, there's a challenge of how do we bring them to the market. Current 5G rollouts are primarily focused on enhancing the mobile broadband proposition, the consumer proposition. The belief and the promise is that the enterprise segment will lead to additional revenues for operators, as well as unlock, in some estimates, trillions of dollars of additional economic value across the various sectors of the economy. I mean, that's why, unlike in previous generations, most governments around the world have a 5G strategy, which they never had for 4G or 3G. The European Commission, for example, published a study which it said, by 2025, more than 62.5 billion euros of first-order benefits can be realized across the 4 industrial sectors. But the question really is how to unlock this potential. And I think, as Tristan kind of alluded to, I think what we see here is the convergence between connectivity and distributed computing capabilities to create these opportunities for customizable networks and also faster rollout of different features for different sets. So instead of having a macro network, I think in the future, in addition to the advances we've made in error-free communication, there's a need to also look at the network architectures and how they could be evolved to support this kind of distributed computing and communications capability. And the third one, I mean, I think Maria touched on this. So it's around the other considerations that come into play. So they are primarily political and societal considerations. So one of them, of course, is as more and more industry and critical services get connected to mobile, the importance of securing that network becomes high up on the agenda. And we see this as one of the drivers here in the UK, for example, for the current desire to diversify and disaggregate the RAN ecosystem. And I think another policy consideration also from for example, from the climate policy agenda is the desire to improve the energy efficiency. The mobile industry globally accounts for less than 0.4% of the carbon of the global emissions. But of course, there's a huge enablement effect of more than 10 times the emissions in other sectors that contribute more to the global emissions. So I think there is a role to also look at beyond KPIs such as 10 times higher speed and 10 times lower latency to also consider other requirements that will feed into the network. I just finish off by saying, so our industry, the mobile industry, is a dynamic industry. It's always innovating. And I mentioned some of the questions and puzzles I think that we still need to solve. Over the decades, we have really made huge progress in the correct reception of bits transmitted over wireless channels, whether it's new modulation schemes, whether it's multi-user MIMO, interference mitigation, and now, of course, in the context of 5G, people are looking at machine learning-based detectors. We are also now making remarkable progress on the network architectures, network slicing, virtualization, disaggregation, these kind of models. And I think in 6G, these kind of elements will probably have a bigger say than purely the advances on the technical front. And I kind of stop there. But really, I think if I look at 5G and beyond, I think on the intelligent combination of transmission technology, whether 5G or beyond 5G, IoT and AI, is really what I think will drive primarily the security requirements. Thank you.
Great. Thanks for your sharing your view. That was great. And moving on to our see a academic point of view for what a 6G testbed would look like from Robert.
Many thanks, Reza. Good afternoon, everyone. It's absolute joy and pleasure to be with you today. I would like to explore confluence of three ideas, and that's emulation, digital twins. I'm going to use these terms interchangeably, AI, machine learning, and naturally 5G, 6G. And specifically, I'm going to address the issue that is the bridging the gaps. So briefly, why we need emulation and what do they give us, and at the same time, the kind of requirements. I'm going to narrow the focus of this pitch. I'm going to specifically look at the problem of sequential optimal decision making for 6G. This is a quite specific and in fact difficult task. So this is a challenging issue. And when we talk about machine learning, what we really data-derived policies. So reinforcement learning and network control, or reinforcement learning for network control. And then naturally, what we also talk about in such context is ML ops, and I have this kind of my own equation here. Being academic, I need to have an equation. So ML ops is DevOps plus ML plus data, and data is the key ingredient, the key summoned in here, and I'm gonna return to it in a minute. So why emulation? Why digital twins? What do they offer us? And in my mind, the biggest benefit is the ability to convert computations into data. Okay, computations are cheap, becoming increasingly cheap. Data is expensive, and specifically, it's not just the data; it's the ML grade labeled data that is expensive. It's cheap, scalable, fast. Scalability, that means we can spin out a number of concurrent digital twins that work in parallel and deliver the goods, deliver the data Fast just means you can run it at much faster than real time. Safety, absolutely a key ingredients. We can try all sorts of crazy ideas, risky strategies, and obviously there's no problem. A canonical example here or analogy is automated transportation. Counterfactuals, again, it's an extremely important factor. What I mean by this is ability to go back in time and check what would have happened had I taken a different decision in time, and then roll back into the future from that point onwards. And you can do it multiple times. Edge cases, another important topic. In machine learning, most of the data may not be very of value. It's only those quirky different cases that will refine our decision-making policy. And on the right-hand side, I do have one canonical example of this. This is more of a converting computing to data. That's AlphaGo, and it's jointly with self-play. Can I have next slide, please? So the question is it all that rosy? What are the challenges? There's obviously multiple challenges. In the second bullet point, I've got the list, and some of them have been already mentioned by my esteemed co-panelists. But I will pick up only on one that derives from this issue of data. What does it mean that we derive policies from data? Well, what that means, that's how we're gonna act in that digital network is directly related from the data that was used to train the agent. And what we also know is that real life, is an infinite source of randomness, has a huge entropy. So it will always be different. Real life will always throw something unexpected. And so when you train your agent and then you deploy it to a real life, there will be, then you should expect issues. And this is particularly acute problem for decision-making for RL. So in the middle, I do have a kind of toy example. So you can see this is an agent that is trained in a period D1. Achieves optimal performance, and that gets deployed, so it goes into production environment on a network, and the performance nosedives. And the reason for that is a slight change. In this case, it's just one parameter. And then we could, in principle, retrain the agent, but this is not a really good idea for the reasons that I've already mentioned. So what can we do? Well, we need to have some remedies. And I think what we should be doing now is watching really carefully automated transportation industry and robotics, because they did encounter that problem a little bit earlier than us. And I've listed here, I'm going to signpost, there's no time to go into details, 3 groups of solutions which are, I think, particularly exciting. The first one is a policy transfer, kind of one more classical one. Domain randomization is the second one. It's actually super counterintuitive. Briefly, it just means adding noise. And the third one, which I'm very excited about, is the unsupervised domain transfer. And this, in fact, started its life in image-to-image transfer. So, just to wrap up, just one message to take home. We will need digital twins, absolutely. And when we design digital twins, obviously, we should strive to emulate reality as close as possible, but at the same time, build in handles so that we can fix the inevitable gap between emulation and reality. And with that, I'd like to stop here. And thanks a lot. Over, back to you, Reza.
Thank you very much, Ralph, for pointing out the importance of digital twin in 6G. Now we are moving to our last but by no means the least presentation of the view of the OneWeb presented by Ben Allen. I believe Ben must share because he has a video his own screen. Yeah.
Good afternoon, everybody. So I'm Ben Allen, and I'm Director of System Modeling at OneWeb. It's a great pleasure to present to you today and to follow on from such eminent speakers that we've had in the panel so far. OneWeb's vision is internet access everywhere for everyone. And our mission is to make a world of difference by creating fast, easy connectivity solutions powered by satellites. So here is a 3-minute video which shows a recent demo of our testbed. And I wonder what our next generation testbed might look like. We'll have a think about that whilst we're watching it, perhaps even out of this world. But enjoy the short video.
OneWeb is a global network of satellites that cover the whole Earth, connecting everyone, everywhere. We're here in Melbourne, Florida to show an early pilot of our satellite network, and we're going to connect our user terminal to the satellite network and back down to Earth so that our customers can see the speed and the low latency and the maturity of our network. This is our gateway antenna. So this antenna is talking to our spacecraft, our fleet of spacecraft as they move overhead, and then talking to literally hundreds of user terminals. So it's connecting the data from the internet, from the cloud, over our satellite network and to our end users and their user terminals. So this antenna is pushing hundreds of megabits per second of data out.
Here we are connecting to the OneWeb satellite on this orbit. So here we have the satellite number 95, which go over Florida, where we are connected.
Very confident about this one.
Yeah, it's going quite well. The SNR are good. And the data rate seems very good, so perfect. Yeah, the SNR is a receive, the ratio between the signal receive and the noise at the terminal side. So this is a metric that we are using to assess the quality of the communication. So here we have around 15 dB SNR, which is very good. And we managed to get 500 megabit there.
Wow, that's great.
So yeah, we can ping there.
Ping session running here. So 32 is
39,
39,
36.
Yeah, 37. Yeah, you can show.
Last time you made 27.
Here we go. I can kind of share the screen. You're looking at yourself in the thing. So I think what's really key here is that, like, I can see you guys speaking, and and the sound is complete. The latency tells the story here, right? This is perfect.
Here you can see that there is two antlion antenna, which are tracking our satellite and switching from one satellite to another when there is handover.
Seeing here is every couple of minutes we hand over, every 11 seconds we're handing over beams, every few minutes we're handing over satellites, but there's no impact on the team session, right? There's no pixelation, there's no jitter. Perfect.
So apologies if that was a slightly corny corporate video clip, but hopefully it showed you a real test bed, which is up there now, and some tests very recently. But why might we need another test bed? So perhaps it's to prove and integrate new and emerging technologies, of which there are some fantastically exciting ones coming, and that might include antennas, protocols, and integration with heterogeneous network to sort of seamlessly include satellite LEO communications, demand modeling, channel modeling, and system modeling. So that's, if you like, digital twin, which has been mentioned, and exactly what my team and I do. But also post-quantum crypto technologies, you'll be able to trial and have confidence in those, and of course new use cases as well. And by the way, our next launch of 36 satellites is scheduled for the 14th of October, and that will take our total to well beyond 300 satellites. And you can watch it live on YouTube. It's super exciting with the countdown and all that on there. So look it up on YouTube, and please look out for it. Thank you very much.
Great. Thank you, Ben, for this great different view of how the satellite can build the future internet infrastructure. Now let's move to panel discussion. Now to all our audience, the floor is open for the question. Please type your question in the question and answer box, and I pick up that. Before that, until our audience are typing the question, I would like to start a discussion. I saw that Paul and Maria, which is basically representing two of our infrastructure owner or provider of the network in this panel, presented a 6G testbed more or less would be a very, from the view of the slide that I got, it was very technology focused. But on the other hand, we saw that Dritan and Rob, they brought basically angle of the digital twin from Rob, and also Dritan brought that more of the other things like a sensing and more of the human aspect of the internet to this. So I want to know, what do you think at the end? Do we need to bring the human or human senses closer to our testbed, or do we need it, or still we do the classically, we go for a better NR, better disaggregation and better software flexibility and programmability, and then deal with the human side of the aspect later on. So I want to go just in random order. Paul, you go first.
Yeah, sure. Thanks, Reza. Yeah, I think it's a very good point. I mean, in terms of, I know one of the things obviously is KPIs when looking at how to establish technologies doing what it should. And that obviously it makes sense that these, as I mentioned, are derived from real world use cases. But I think as you say, the human element, I would almost translate in my head as well to the end user experience perspective, you know, focusing on potentially defining service quality and focusing on abstracting from the typical KPIs that we always hone in on from a technical perspective, like jitter, latency, throughput, all these kind of things. If as a test bed, we can take more of a holistic system view, which I think many of the panelists have discussed, that service quality metric could be formed from a combination of those more technical APIs, but we can get more of an accurate picture of what the end user experience would be for a given application or a given use case. And I think that in a way, such a testbed should be able to really stem from, okay, what's the use case we're testing here? What's the application? And then what are we delivering? Is it successfully providing that? So yeah, I think that would be my perspective, if that's what you meant by the human element there.
Okay, thank you. Maria. You are muted, Maria. You are muted. Maria, sorry about that. I just.
Thank you. I was double muted there.
Yes.
Thanks for spotting. I'll repeat that again. So I was just saying, I agree with Paul. My reading of bringing the human element into this has to be driven by the use cases, which I think we've all stated that have to be very important. So I don't think when I lay out my requirements, I was necessarily implying that we have to be very much technology focused. Or only technology focused, I should say. So I think there is value in obviously having, if you like, domain test beds that will focus on one technology and obviously get very, very deep into the detail of them. But there is going to be, and I like the I suppose, layered model where, you know, you almost have those domain technology focused test beds, but you do need obviously to add all of the other layers, right? Whether it's a transport element of it, because we have a distributed infrastructure, whether it's the digital twin aspects that Robert spoke about, because we do need to bring that into the picture. But that interdisciplinary test bed as well, that brings all the different use cases and where we're able to test different use cases over the architecture. So it's almost figuring out how can we increase the collaboration between the test beds to tackle all of the above, in my mind, rather than maybe focusing on one particular area and never going out into all the other domains, if that makes sense.
Okay, thank you. Dritan, what is your view? I mean, how we can, you said sensing in your test bed. I mean, how we can add this as a test bed, how we can measure it, and what would be technology for that?
it's quite an interesting thing, because there are two elements in a way, and we face it in 5G quite acutely now. Everyone, Paul mentioned it, and Manu certainly mentioned it, and everyone is aware of a bit of the hype element. And the hype element was because there were certain KPIs which were targeting certain application, and it's not characteristic of the 5G generation. It's also 4G and 3G as well. So there is an element there of the mobile industry facing a consumer market, trying to effectively address, but also sell up and scope the requirement for the communication platform. And what we are seeing now, and what I try to say, and I agree with Maria, is that we cannot continue to be that kind of self-isolated in a way that we are delivering a system that provides this capacity. Those are absolutely necessary for all of the engineering work that we need to do, and cascading from that for all of the applied R&D that needs to happen in the next 5 years for certain, and it's happened before. But it is quite important to go back to what also Paul said, that there is a direct, reasonable, and verifiable link to what the capabilities of what the system is delivering, what are they going towards to, so that we don't have to do the same thing that we did in 5G, where we are still struggling to find applications where the latency is important. We all know that latency is important, we all can make the case, but there were no kind of tests, and there are still quite rare tests that effectively say, okay, how can that latency be achieved? And where can the latency be achieved in a whole technology stack, not just in the communication layer? So I would go and expand on this side first, and the second one is to integrate and include. We will be designing a communication system that will deliver services in 2030. In 2030, the world will be unbelievably different from what we have today. It's amazing. We take for granted the electric vehicles and the experiencing of Teslas, etc. But I don't believe that any one of us will effectively own a car by then or want to drive it on a motorway. How do then interact or bring the expectations of a completely new way of living to effectively put that into a iterative feedback loop, into translating into the KPIs that we as engineers need to deliver against in the system? And I think that is where the human side needs to come in, and that is why the interdisciplinary testbeds are not only to test the applications once the technology is matured, but they need to be done much earlier, because they effectively feed on and off each other. And that would be my view. And a perfect example of this, so I want to go beyond the testbeds that we have today, but going more towards the Bristol Digital Futures Institute reality emulator concept, which effectively is trying to bring a more socio-technical aspect, where the input from human experience of the technology influences the way that the technology itself is developed at a much earlier stage of the technology development than we have today.
Thank you.
Sorry, long explanation, but yeah.
Thank you. So I am interested to know the Mani's view from a standardization point of view. What effort you think should be taken to basically form structure these points that Maria, Paul, and Dritan mentioned so far?
Thank you, Reza. So let me say it this way. So I think that the communication as an application and then enhancing the types of communication, I think is an application that primarily mobile networks have to serve also in the future. So I agree to some extent that that the focus shouldn't be purely on increased data speeds and reduced latencies. But I think none of us would have expected, I don't know, 10 years ago, that in the 4G decade, maybe we would have forecasted that social networks would have taken off, but we would never have, at least I wouldn't have expected ride-sharing applications to have such a huge implication. So I think it's sometimes very difficult to forecast what applications will be provided when network capabilities increase. So I still believe that in the public networks, where it serves primarily consumers, these advancements in terms of the number of bytes carried, the throughputs that are delivered to consumer devices, those kind of KPIs will still be increasing. And that's still a testing methodology of testing at the bit level, the symbol level, and the packet level, and the application level, and making sure that it serves those consumer cases. But I also agree then there are other KPIs. So I think we already see that in the world, there are about 175, let's say, commercially rolled out 5G networks. There are more than twice that number of private wireless networks already installed. So we will see more customized networks with different performance requirements and KPIs. So I see a kind of maybe a fragmented, the way that networks are getting disaggregated to serve different purposes with different KPIs. I think the testing methodology and test systems also have to get fragmented to serve and test these different capabilities. So that's how I think, that's how I look at this question that you answered.
Thank you. Ben, I want to know your view on that. What do you think? I mean, role of the satellite communication. Obviously, you emphasize of your video was a lot on the latency. What do you think in this context of what we are discussing now, bringing the basically human-related aspect or experience of the human-related aspect to the picture? What would be the role of your type of technology that your company provides, basically?
Well, firstly, the positioning currently is to complement terrestrial networks, really, and to go perhaps where terrestrial networks can't, and to complement to where that's needed on an absolute global basis, and to be able to connect in perhaps rural users in corners of the world which have nothing at the moment, no connectivity whatsoever, and that's one of the primary missions of OneWeb. Which is super exciting, trying to close the digital divide. And that's all about people and economies then, in the end, on the big scale. Perhaps on the more kind of technical business scale, looking at, I think somebody mentioned earlier, the end user experience and looking at verifying appropriate service level agreements and service quality is super important, and part of what we do now and will continue to do. Another aspect which could be something that satellites provide more of in due course would be IoT via satellites and sensors. So again, that could be sensing the environment in which we reside. So that would touch on people, perhaps indirectly, but nonetheless touching on people. I think it's really important, though, from a testbed perspective, amongst all the other things, is to be able to test the integration of satellite comms to make a truly heterogeneous network. Often the terrestrial world, or perhaps satellite comms in its new context is new, and integrating that into existing and future networks seamlessly, perhaps from standards outwards and also technology inwards. And another aspect, of course, is users and security. So if we have end-to-end security, I'm thinking of the post-quantum world, especially now, to underpin user confidence, whichever that user might be, banks in the finance, or even just individuals using it as a broadband alternative. And another element that people spoke about just now was having different disciplines, multidisciplinary. And of course, the world of satellites is, well, whilst we're delivering a telecoms service, in my team we have aerospace engineers, and we have, and in the wider company we have people working on satellite payloads, planning launches, working with people who build and launch rockets for us. We have power and thermal engineering. So in that sense, there's a lot of interdisciplinarity that goes on in the world of satcoms. Anyway, Reza, there's a few words from me in response to your question.
Thank you. And Rob, I would like to expand in a slightly answer to the question in different direction. You mentioned AI a lot in your digital twin view, but do you think we need to 6G would be also the testbed would be a platform for testing new type of AI, or a ground for the fostering new type of AIs in a telecom environment?
I'll try to touch on this element of human element and try to reformulate. So maybe rather than thinking of purely human, I'll reformulate it as an end user with the technology. And I think that the main role, and in the context of AI, would be ability to bring data. So data from real life. So crowdsourcing the data collection problem. How do we do that? Obviously, anonymized, and it's how do we get a purchase from the public that public would happily participate in such an exercise. And Dritan mentioned Tesla, and I think Tesla is the master of this. They are in many ways absolutely disruptive AI company. And Tesla, if you have Tesla, when you drive your car, the car collects the data for the company. All the sensors collect the data. It doesn't do it all the time. What it does, it just collects the edge cases. So how do we kind of replicate that kind of setup so that we'll have the end users that do this happily and collect kind of interesting data so that we can train then AI agents. I think that's the kind of challenge, for the digital twins, AI, and how do we crowdsource it? How do we gamify as it were this problem?
Okay, thank you. I mean, that's interesting. Now we are approaching end of the panel, but I want to put one last question, and I want a short answer if possible. When do you think, from your point of view, we will have a 6G, at least starting to we use 6G in our mobile phone? I start with Maria.
I'm going to give you a very short answer: when customers need it.
Great. Paul, I guess it's the same answer from you.
Yeah, pretty much the same, when it's needed.
Yeah. Okay. So, but from technology point of view, that would be great if you have a view of a timeline as well.
Yeah, I mean, I think obviously the kind of IMT sort of views is sort of pushing towards 2030, as I think Dritan's mentioned. But again, I think the path towards that is going to depend on how 5G satisfies applications as we move forward, and how much of a drive there is for things that we can't do with 5G.
Okay, great. Mani?
So yeah, I think as the technological capabilities of 6G might be available from 2030 onwards. But until 2030, it's not going to be a 5G decade. It's going to be a 4G decade for many parts of the world. So I think even 2030 plus, you're going to see more 5G networks, 5G advanced networks, rather than 6G to be commercially deployed.
Okay, Ben?
Well, the world of satellite communications in this context, and LEO satellite comm, seems to be a little bit out of step with the terrestrial world in a way. And so in that sense, our next generation is being worked on right now, and that could be a few years' time. I haven't given it a name or a number on purpose because it's out of step. But if we sort of adopt the broadly accepted what is 6G and when that might be, then I'm going to shrug and say, 2030, which I think Mani said kind of sounds broadly good to me. And as a final comment, that seems to be roughly in step with what we would call the post-quantum world as well, and security, which I think is super important.
Okay, Dritan.
It's a market. It's a market. It's more of a market tool than a technology, and everyone is talking about using it as a threshold capability changes rather than anything else. If history serves us, then 2032, 2033, we'll probably see what we will call 6G networks, but there will be step changes primarily because of quantum and network management capabilities with AI that probably will shift in the direction. But if it will be a waterfall change or a continuum, 5G and a half, 5G.9, 6.0, like Manu said, I don't know, but 2030, 2032, not the least, not to leave Etsy and Paul without any job in standardization terms.
Okay, we have by the way, we have a comment from audience says that don't hang on the 6G term, just think about the 5G plus instead. Yes, so that's I think that's a valid point from the audience. Okay, Rob, your view.
I'll carry on with the machine learning theme. So if we were to train agent on the data we already have, we have the training data. Every G happens every 10 years. You fit it. Prediction is very simple. 10 years from now.
Okay, great, guys. Thanks for your very thoughtful discussion, and Great to have you on the panel. It was very interesting. I truly enjoyed. I am sure audience we have enjoyed that. And thanks again for your time. I mean, we cannot have a cheers you up when if you are not face to face. But thanks again. Okay. I hope I see you soon in the other virtual conferences or physically. Okay. Bye.
Thanks a lot.
Thanks, Reza. Thanks,
By the way, I
everyone.
believe there is a remote conference, I think, is happening. I don't know, conference support, if they want to say anything, is a networking session.
We just click on it.
Okay.
Yeah,
Yes,
I think there is a
session with a link in the chat.
there is a link. There is a networking session that everybody comes. There is a virtual networking session. That would be great if you can join. I believe you have a detail of it. And yes, thanks again, and thanks all the organizer, especially Aneta and Becky that were presented today. Okay, see you in the networking session. Bye.